So number 41 from homework. On a stretch of interstate, a vehicle's tires range between 646 and 840 revolutions per minute. The diameter of each tire is 26 inches. 26 inches, all right? So the first question is find the range of values for the angular speeds of the tires in radians per minute. Radians per minute. So we go back to angular, all right? So angular is what? What's our angular speed? Theta over t. All right. In order to find theta, we have to do what with our revolutions? Change them into revolutions, right? And so what do we multiply them by? So to find theta, so we're going to start with the 646 first. We'll do this one, 646. All right. So my theta then is going to be 646 times what? 2 pi. What is that? Just in pi. 1292. So my theta here is going to be 1292 pi, and it's already per minute, and that's what it asked for in my question. So 1292 theta radians per minute. I'm actually done with that part of that one. Let's look at 840 revolutions per minute. What do I need to do with that to convert it to theta? Just times 2 pi, which gives me what? 1680 pi radians per minute. Now, if it were in minutes and they wanted in hours, I would have to do some conversions, right? But they wanted it in revolutions per minute and radians per minute. And so it's in the same units. I just have to multiply by 2 pi. So that piece of it is done. That is A. All right, let's look at B. B says find the range of values for the linear speeds of the tires in miles per hour. Okay, so linear speed, let's go to that guy. That formula is going to be what? What's my linear speed formula? S over T, all right? I need S. What is my formula for S? Theta times R. I need both of those to be able to solve this, okay? So for this one, I am going to take theta that I've already figured out, 1292 times R. They gave me the diameter. So what is my radius? This is the diameter. What is my radius? 13. 13. And I'm going to leave it right now. So this is going to be 1292 pi. 1292 pi times 13 over my time right now is still 1 minute.
Why is it 13 again?
Because my diameter is 26, I need my R. Take your diameter and cut it in half. Now in this particular case, I have it per minute. They want it in miles per hour. Miles per hour. So I'm going to have to do some converting here, right? So I already have my S over T, and I'm not multiplying it out right now because I'm going to have to do some multiplication when I convert it anyway. All right? So how do I change minutes, or how do I change, what am I in right now? It is inches. So I am in inches per minute, and I need it in miles per hour. I need to do some converting. How do I convert it?
You start with?
You can start with either. All right, so let's start with the minutes and change those to hours. How many minutes are in an hour?
60.
So 60 minutes per 1 hour. All right. And I'm going to walk through from inches to feet to miles. Okay. How many inches are in 1 foot?
12.
So I'm going to do that conversion. And then how many feet then are in 1 mile? 5,280 feet. All right. All right, 5,280 feet. So then what you're going to do is you're going to multiply across. You're going to say 1292 times pi times 13 times 60 times 1 times 1. And you are going to then divide it. And you do have to put parentheses here. So in your calculator, when you do this one, you must do, you don't have to do parentheses at first. That's not as important. But basically, you're multiplying 1292 times pi times 13 times 60. And that group is divided by 1 times 12 times 5,280.
What mode should our calculator?
One thing you do want to check when you do this is that you did all your conversions. So this will keep you from not doing a conversion. You can cancel them out. So my inches canceled out with inches, my minutes canceled out with minutes, and my feet canceled out with feet, and I was left with miles per hour. So here I should round it to the nearest whole, 50 miles per hour. All right, so then the second piece is the same exact thing. We are going to take the 840, or not the 840, that we've already multiplied that one, so we don't have to multiply that again. We're going to take the 1680 pi, that's my theta, times my r, 13 inches, to 1 minute, and we are going to do our conversion. Exactly the same as we did before. So we're going to take this exact conversion and we are going to do it again with this one. And when you do all of that out, don't forget how to do it in your calculators, but you should get rounded to the nearest, should get 65 miles per hour for that one. And so your range would be from 50 to 65 miles per hour would be your range. All right, trigonometric functions on the unit circle. We're going to start with any trigonometric function at any angle anywhere on the coordinate plane. And we're going to talk about how we calculate this using right angle trigonometry. All right, so if we look at what they've done over here, they have started this angle over here on the x-axis. It terminated over here. And so what's created are these right angles, all right? We've created these right angles. So if this is my angle here, then my base of my angle is x, my height of my angle is y, and the radius is my r. And I can calculate the radius by x squared plus y squared by Pythagorean theorem, right? So I have this right triangle right here that I'm talking about. This right triangle right there. All right? And so if I'm using this angle as a reference, the opposite side is my y, right? Because the length of this guy is going to be y. Everybody see that? The length of that guy is y, because that's how far I went down. All right? And so if I were to calculate based on just SOHCAHTOA, it would be opposite over hypotenuse, y over r. All right? Make sense? If I were to do, based on this angle right here, if I were to do cosine, adjacent over hypotenuse. And so if I were to label this entire angle based on this guy right here, this would be adjacent, this would be opposite, and this would be my hypotenuse. Okay? And I could simply do SOHCAHTOA throughout that entire thing based on that, creating that right triangle, okay? So when you do that anywhere on the coordinate plane, you create these 6 functions. It will always work on the coordinate plane. My sine will be my y over my r, y over r. My cosine will be my adjacent, or x over r, x over r. My tangent will be opposite over adjacent, y over x. Ready? You see that? Okay? So my y over r, sine, my x over r, cosine, and my y over x, tangent. And then, of course, we know reciprocals. So cosecant would be r over y, secant would be r over x, and cotangent would be x over y. All right? This works anywhere on the coordinate plane. Now, you may have to calculate your r, okay? They may just give you the x, y, but calculating the r is strictly the Pythagorean theorem. That's how you calculate your r. That is the base, the height, the hypotenuse of a right triangle. To calculate the hypotenuse, Pythagorean theorem. So let's look at the example here. Let x negative 6 be a point on the terminal side of angle theta in standard position. Standard means it's just a positive angle, all right? Find the exact values of the 6 trig functions, okay? They have given me x and they have given me y. I need to calculate r. So my first step here is to calculate r using the Pythagorean theorem, all right? R is going to be the square root, right? Because it's going to be squared, of a squared plus b squared, or my x squared plus my y squared. R will always be positive because you're talking about a root here, okay? R will always be positive. All right, and this stems from Pythagorean theorem, right? Which is my x, my y, and my r. X squared plus y squared equals r squared. So to find r, I take the square root of both sides. So this is how I get r. So I'm going to calculate it. What is 8 squared? And then 6 squared, negative 6 squared is? So I have the square root of 100, so my r is 10. And then I'm just going to do my 6 trig functions. My sine of theta is y over r. What is my y? Negative 6 over 10. I'm going to reduce it to negative 3 over 10. Over 5, not 10. All right, negative 3 over 5, right? My cosine is x over r. So I'm going to reduce that. And my tangent is y over x. And I'm going to reduce that as well. So I have my sine, cosine, and tangent. All right. The other three are simple. We're just going to reciprocate it. Cosecant is going to be the reciprocal of my sine, negative 3. My secant is my reciprocal of my cosine, 5 over 4. And my cotangent is my reciprocal of my tangent, negative 4/3. So when you did this, you should have gotten an r of square root of 5. So your sine is negative 1 over square root of 5. You need to rationalize that. Square root of 5 times square root of 5. You get negative square root of 5 over 5. Cosine would be negative 2 over square root of 5. Same thing, multiply top and bottom by square root of 5. Negative 2 square root of 5 over 5. And tangent would be y over x. Negative 1 over negative 2 is just positive 1/2. Cosecant just reciprocated. And I always go back to this one to reciprocate it. The first one, because then you will have to rationalize it. So when you flip that, you just get negative square root of 5. When you flip this one, you get negative square root of 5 over 2. And of course, when you flip this, you just get 2. So let's look at these common angles here. You have a common angle right here, 0 degrees, right? 0 degrees. Your x is whatever your radius is, right? and your y is 0. So if I'm going out here, whatever my radius is my x, and my y is 0. So if I put my values here, x would be r over r, so my cosine would be just 1. My sine would be 0 over r, that would be 0, right? And so at this point, my x values are and my y value is 0. When I come up here, my x value is 0 because I haven't gone left or right, and my y value is r. When I come all the way over here, my x value is negative r, and my y value is 0. And when I come way down here, my x value is 0, and my y value is negative r, okay? Because I'm creating a circle, right, with a radius of whatever it is, right? So this point, my radius is r, this point, my radius is r, this point, my radius is r, and this point, my radius is r.
And what about if it's
When then we put this into something like this. Sine of negative 180. So we went this way, and we ended up at the point negative 1, 0. Negative 1, 0. They want the sine. Sine is what? Y over r, yes?
yes?
Sine is y over r. What is my y value right here on the x-axis? What's my y value right here? They tell me. What is my y value? 0. What is my radius?
-1.
It's negative 1 because it fell on this point right here. Yes? So that's the distance from my center. So 0 over negative 1, my sign here is 0. How about tangent of 3 pi over 4? 3 pi over 4 falls right here on this axis, right? Tangent is what? Y over x, yes?
Yes.
What is my y value?
-1.
What is my x value?
0.
What's the problem?
Negative,
I'm dividing by a?
negative.
I'm dividing by a 0, right? The tangent of 3 pi over 2 is undefined. All right, let's look at secant of 4 pi. Any even pi, 2 pi, 4 pi, 6 pi is always going to fall right here because that's a full circle. All right, secant is the reciprocal of my
Your
cosine. My cosine is x over r, so my secant is r over x. What's my radius here? Distance from 0. What's this distance? That's my x value, right?
4.
My x value is
Your
1.
x is 1.
All right. And my radius is 1, right?
Oh, okay.
So my secant here is 1.
I was looking at the 4 pi down there.
So anytime it falls on an axis, your radius and one of your variables will be the same. If it falls on the x-axis, your radius and your x will be the same. Y-axis, your radius and your y will be the same. All right? Now, what happens then is you can solve for these guys. All right? 270, 90, 180, 270. 270 looks just like this, right? This is 270. So I want the cosine of a 270. Cosine is x over r, all right? X over r. Does it matter what my r is? What is my x value on this particular angle? It falls on the y-axis. What is my x value always on the y-axis? 0. So 270 is always going to be 0 over r. So that's always going to be 0. All right? What about this next guy? Pi over 2. Pi over 2 is right here. All right? Right here. What is my x value right there?
1.
X value on the y-axis, 0. All right? My y value,
-1.
+1. All right, if my radius is 1. Okay? Cosecant is the reciprocal of which one?
Your sine.
Your sine.
Which
So,
is r over y.
right. What I know about this is my r and my y are the same thing right there, yes?
Yes.
So I end up with r over y, which are the same things. So anything over itself is 1. All right? Let's look at negative 90. Negative 90. Negative 90 is right here. What's my x value at negative 90? On the y-axis it is 0. And then I have a y value, yeah? Right? What's my cotangent? Cotangent is x over y. Yes, x over y. So that one's going to be, so this one's going to be 0 at negative 90. All right?
So you're just.
So what happens then is you can start using some of your common angles because they are always going to happen the same way. All right? They're always going to happen the same way. And so it just changes what quadrant it's in, because plus positive and negative. All right? So if I have an angle right here, and let's say this particular angle is 135. All right, so let's say this particular angle is 135. All right, that means that this angle over here is 45. How do I know that? It's because the half of the circle is 180, right? Does that make sense? So if I have just created 135 here, what's left is going to be 45 degrees because this straight line here is 180. Everybody agree a half circle is 180? Now, what do you notice about the 45 degree angle and the 35 degree angle? Well, their x, y, and r are the same exact thing. It's just that the 135 has a negative x and a positive y, and the 45 would have a positive positive. All right? So what happens with reference angles will have the same sine, cosine, and tangent as their supplement. So what do I mean by supplement? Adds up to 180, right? And so they'll have the same ones, except they'll just have different signs. And so what you can start doing is if you remember the 30, the 45, and the 60, remember I said those are going to be important angles, 30, 45, and 60. And if you know those sines, cosines, and tangents, then all of a sudden you start having reference angles that you can use those for. All right? Because they end up with being the same exact x, y, and r. X, y, and r ends up being exactly the same. And it just changes. So you have to figure out, where does my terminal side end? If my terminal side ends in my first quadrant, my x and y value in my first quadrant is what for both of them? Positive. If it ends up in the second quadrant, though, my x value is negative and my y value is positive. Third quadrant, they're both negative, right? And fourth quadrant, and it actually was wrong in my book. I had to change it. Is it wrong in your book as well? In this last quadrant,
So it's just A is positive.
it's a positive A and a negative B.
That's
All right? Positive A and negative B. And so as long as you can figure out what quadrant this ends in, then you can use its reference angles to help you. And so here's where it's talking about your quadrants down here. The first quadrant, positive, positive. Second quadrant is going to be negative, positive, negative, negative, positive, negative. And what you do is you look to the closest x-axis to determine what the reference angle is. So if I'm here, my reference angle is whatever the angle it actually is. But if I fall into the second quadrant, I have to subtract it from 180 to get what that is. If I fall into the third quadrant, I take my angle and subtract 180 from it. And if I fall into my fourth quadrant, I subtract from 360, because that's going to be my closest. So first quadrant is what it gives you. Second quadrant, subtract from 180. Third quadrant, subtract 180 from your angle. Fourth quadrant, subtract your angle from 360, and that will give you your reference angle. All right, so let's look at the example. All right, sketch the angle. I'm not as concerned about you sketching it, but it does give you a little bit of a visual. All right, so if I sketch this angle, 300 is going to fall in what quadrant? Well, it's important to know where your markers are. This right here is 90. This is 180. This is 270. So which quadrant is 300 going to fall in? My fourth quadrant. So that's going to be somewhere over here, right? So I'm going to have to subtract from 360 to get my reference angle. 360 minus 300 gives me a 60-degree reference angle. All right, let's look at the next one. Negative 2 pi over 3. All right, so this is pi over 2. This is pi. This is 3 pi over 2, and this is 2 pi. If I'm going in the negative, this is negative pi over 2, this is negative pi, and this is negative 3 pi over 2. All right? So, pi over 2 to pi, to 3 pi over 2, I need to figure out where this is. Where would negative 2 pi over 3 fall? Get a common denominator, by the way. What's the common denominator between 2 and 3?
6.
So this would be negative 3 pi over 6, right? This guy would be negative 4 pi over 6. Where's he going to fall? If we're going this direction, he's going to fall over here, right? Yes? Yep. All right, so we're closest to this particular one here. And we have to subtract it from that guy. So what do? What is pi? This is going to be 6 pi over 6, right? How far away is negative 4 pi over 6 from negative 6 pi over 6? How far away is it? So negative 4 pi over 6 minus a negative 6 pi over 6. How far away am I?
2 pi.
Or pi over 3. What's pi over 3 in degrees? Do we know? Those are one that you're going to have to memorize, by the way. It's 60 degrees. Valuing trig functions of any angle. So the first thing you want to do is you want to find the reference angle. If the reference angle is one of these common angles, 30 degrees or pi over 6, 45 degrees or pi over 4, and 60 degrees or pi over 3, you need to memorize the sine, cosine, and tangent of these three angles. You will see it on your unit circle that we're about to do over and over and over and over. You need to memorize the sine, cosine, and tangent of these three angles. This chart must be memorized going forward. Because then if your reference angle is one of these, you automatically know your sine, cosine, or tangent. The positive and negative may change depending on what quadrant you fall in. Sine will be positive where y is positive. Cosine will be positive where x is positive. And tangent will be positive where sine and cosine have the same sign. All right, so if you think about a coordinate plane, sine is going to be positive in 1 and 2, right? Cosine is going to be positive in 1 and 4. And tangent is going to be positive in 1 and 3, right? So just think about your x's and y's and where they're positive and negative. And that's where your sine and cosines are going to be positive and negative. They will follow that. Sine is y, cosine is x, all right? So you need to memorize these guys right here for these three. So how does it help us? Well, find the exact value of these expressions. They want the cosine of 120. What quadrant is 120 going to fall in? It's going to fall in between 90 and 180. What quadrant is that? The second. All right, so it's going to be in the second quadrant. So first of all, we need to know it's in the second quadrant. In the second quadrant, is my sign positive or negative in the second quadrant? We're talking about the x value. So it's going to fall somewhere in this quadrant, and then with the x value. So I know my cosine is going to be negative. I'm going to have a negative cosine. Now I'm going to look at my reference angle. If I am at 120, my closest x-axis is 180. So what is my reference angle for my 120 degrees? It's 60 degrees. That means they will have the same cosine, except this guy will be negative. So what is the cosine of 60? Look at your chart on page 245. What is the cosine of 60? All right, the cosine of 60, cosine of this guy is 1/2. So the cosine of 120 is going to be negative 1/2. That is my answer. That is the x value of the right triangle that is created with a 120-degree angle. It is the adjacent over the hypotenuse, all right, of a 120-degree angle. All right, let's look at 7 pi over 6. Let's think about this guy. So anytime I have pi in my brain, I automatically put my pi over 2, my pi, my 3 pi over 2, and my 2 pi. So 7 pi over 6. Pi would be 6 pi over 6. So that means 6 pi over 6 would be right here. So where in what quadrant would 7 pi over 6 fall if 6 pi over 6 is right here?
3.
In the third quadrant. Third. All right? Tangent is my sine over my cosine, or my y over my x, right? Sine over my cosine, y over x. Sine is your y value, x is your cosine value, right? So if I'm talking about in this quadrant right here, what is my x, positive or negative? Negative. What is my y, positive or negative? So my tangent's going to be positive in this quadrant, right? So now I need the reference angle of pi over 6. My reference angle is going to be pi over 6 because it's the difference between 7 pi over 6 and 6 pi over 6, right? So just 1 pi over 6 is my reference angle here. Pi over 6 is also known as 30 degrees, right? 30 degrees. So what is my tangent of a 30-degree angle? It's square root of 3 over 3. It is going to remain positive because it is in the third quadrant. Let's look at the last one. 15 pi over 4. All right, this is going to go around a couple times. All right, so if I talk about pi over 4, all right, my pi over 2, that's going to be 2 pi over 4. My pi is going to be 4 pi over 4, right? What is 2 pi if I put it in terms of 4? So what is 2 pi? So if I'm going to convert 2 pi over 1 to a denominator of 4. What do I need to do? I need a common denominator of 4. So what do I do to this guy? Times what? Top and bottom times 4, right? So 8 pi over 4 would be right here. 8 pi over 4. Does everybody see what we're doing?
Why would it be right there?
Because that's 2 pi. This is 2 pi. And I just got a common denominator. All right? Everybody see what's happening here? All right. I can divide it if I want to. What would happen if I divided that? 15 divided by 4. How many times does 4 go into 15?
Or 12.
3 times with a remainder of 3, right? So where would just 3 pi be? This is 1 pi, this is 2 pi, this is 3 pi, right? So then another 3 pi over 4, right? Another 3 pi over 4. Where's that going to fall? What quadrant? From there, I need to move another 3. This would be 2 pi over 4 right here. So 3 pi over 4 is going to fall over here. So 15 pi over 4 is going to be way over in the fourth quadrant. You're actually going to loop all the way around. Another pi over, like 2 pi over 4, and then one more pi over 4. It's going to go all the way around to the fourth quadrant. Cosecant, that's the reciprocal of which function? Sine or cosine? 1 over sine, right? It's the reciprocal of my sine. So my y value in this quadrant is what? Positive or negative? Y value?
Negative. Oh,
Negative. So my cosecant is going to be negative, all right? I'm at 3 pi over 4, or 3 and 3 pi over 4, so I'm right here, pi over 4. My closest axis is here. So if I am at 15 pi over 4, my closest axis is actually going to be 16 pi over 4. All right, so this side of the, let me just point this out really quickly. so you understand. Anytime you get an even, right? An even times pi. So let's say 2, 4, 6, 8, whatever. Even. Something even times pi. That's going to be over here on this guy. Anything you get something odd times pi, 1 pi, 3 pi, 5 pi, that's going to land on this side. All right? So even times pi, 0, 2, 4, 6, 8, whatever, right there. Odd times pi, that's going to be right here. All right? So that's going to be one of your special cases. So if I am at pi over 4, which is 15 pi over 4 right here, I am pi over 4 away from my axis. So my reference angle is just pi over 4. Pi over 4. What is the sine of pi over 4? Square root of 2 over 2. I need the reciprocal, so 2 over square root of 2, right? How do I simplify 2 over square root of 2? Yep. Yep. 2 square root of 2 over 2. That reduces to square root of 2. I need it to be negative square root of 2. So that one was the hardest for sure. All right, let's walk through these. 5 pi over 3. 5 pi over 3. So let's look at if we were to have our coordinate plane. Okay. Where would 1 pi be? So if I were, here's pi, right? How would I label that as a denominator of 3? That would be 3 pi over 3, right? 2 pi, that would be 6 pi over 3. Yes? So where would 5 pi over 3 fall? Fourth quadrant, right? That would be 5 pi over 3. Yes? Looks like Pac-Man. Right? How far away is 5 pi over 3 from your 6 pi over 3? What is your reference angle here? How far away is 5 pi over 3 from 6 pi over 3? How far away is 5 from 6? 1. So pi over 3 is my reference angle. That's actually a 60-degree angle. What is the tangent of my pi over 3? What is the tangent of pi over 3?
The tangent is square root of 3.
So square root of 3.
Yeah.
In the fourth quadrant, is your tangent positive or negative?
It's negative.
Because it's y over x, right? Which is negative over positive. So this guy right here is going to be negative square root of 3.
Okay.
Negative square root of 3. Okay? Let's look at the next one. Let's look at the next one. All right? 5 pi over 6. We have our coordinate plane here. All right? Here is 0. Here is 6 pi over 6, also known as pi, right? So where is 5 pi over 6 going to lie? Just above the 6 pi over 6, right? Second quadrant right here. This is going to be 5 pi over 6. How far away is 5 pi over 6 from 6 pi over 6? Just pi over 6, right? Which is also a 30-degree angle. What is the sine of pi over 6?
It's 1/2.
It's 1/2. Is my sign positive or negative in this quadrant?
Negative.
My sign is my y value. Is it positive or negative?
Positive.
Positive. So this is going to be positive 1/2. Positive 1/2.
So
All right, so this next one looks just like what we did on right angle trigonometry. This looks just like what we did on right angle trigonometry. It is on page 246 in your books. The difference is all of a sudden they give us a little bit more information. In right angle trigonometry, it was assumed that your A, B, and C were all positive because we were talking about measurements of a triangle. So if they gave you sine, they gave you opposite over hypotenuse, both being positive, right? However, when you move to unit circle trigonometry, you have to consider changes that could happen with your positives and negatives. While the same ratios will yield the same trig functions, the positives and negatives may change. okay? So 5 and 12 will always give you the same radius, okay? But where it is in the coordinate plane will change your positives and negatives. And so for this one, they said, let tangent be 5 over 12. So tangent of theta is pi over 12. Sine is less than 0. So they told me, let's figure this out. They said, okay, I'm giving you a tangent of 5 over 12. Let's make that a little straighter. 5 over 12, okay? So they've given me a tangent of 5 over 12. Is that tangent positive or negative? What did they tell me? 5 over 12, is that positive or negative?
Yeah.
It's positive, right? So my tangent is positive, we know for sure. Then they gave us this little bit of information. My sine is negative. So sine is negative here. And sine is negative here. We're talking about my y value, okay? My y value. If my sine is negative, but my tangent is positive, where does this angle fall? My sine is negative, but my tangent is positive. What do we know that has to mean about our cosine? If my tangent is positive, but my sine is negative, what is my cosine? It has to be negative because I have to have a negative over a negative to create a positive there. So where is my cosine also negative between these two? Third or fourth quadrant. Where's my cosine? Third. Cosine is also negative here, which means my tangent is positive. That fits all the criteria they just gave me, right? They want the exact value of the 5 remaining trig functions. So I'm going to use my right angle trigonometry information to get the rest of my stuff. They have given me y and x, right? They have given me tangent. Remember, on any angle, my tangent is y over x. What they did not give me is r. We don't know what r is. How do we solve for r when we have y and x?
Squared.
Yeah, Pythagorean theorem, right? So we have x or y squared plus x squared equals r squared, correct? What is 5 squared?
25.
12 squared.
144.
You add those, you get what?
169.
Has a perfect root. What is my perfect root of 169? 13. So I know my y, x, and r. Specifically, I know that my y is negative 5, my x is negative 12, and my r is 13. Correct? So I can do all of my trig functions here. My sine of theta is going to be y over r, negative 5 over 13. Cosine, that's going to be x over r, negative 12 over 13. Tangent they gave me. Reciprocal, cosecant, negative 13 fifths. Secant, negative 13 twelfths. Tangent, 12 fifths.
Why do you have to make them negative and positive?
So for this one, you should have calculated your x. They gave you your y over r. So 5 squared plus your x squared equals your r squared. 49 minus 25, square root of that is 2 squared is 6. So cosine is going to be x over r, 2 squared is 6 over 7. Tangent is going to be your y over your x. So 5 over your 2 squared is 6. So if you do that out, 5 over 2 squared is 6. You multiply top and bottom by that square root of 6. Get 5 square root of 6 over 12. That's how you get that. Cosecant is just the reciprocal of your sine. So if sine was 5 over 7, cosecant 7 over 5. Secant is your reciprocal of your cosine. 7 pi over 6 over 12. That's what's going to happen when you rationalize that. And then cotangent is your reciprocal of your tangent. Your tangent was 5 over 2 squared root of 6, 2 squared root of 6 over 5. All right, so this is the introduction of the unit circle. At this point, we have done any point on the coordinate plane. Radius being the a squared plus b squared with the Pythagorean theorem, okay? Unit circle gets its name because the radius of a unit circle is 1 unit, okay? The radius of a unit circle is 1. So if you take all of those trig functions of any circle, sine of any point on the plane is y over r. But on the unit circle, sine is just y because your r is 1. So instead of y over r, you just get y because it's y over 1. All right? Your cosine on the unit circle, instead of x over r, is just x because your radius is 1. Your tangent's y over x, just like from what we've been doing on the coordinate plane. Cosecant then is 1 over y. Secant is 1 over x. Cotangent is x over y. We are still talking about the xy value of where it falls. So if this is my angle T, the termination side is here, but it always terminates at a radius of 1 on the unit circle. So this point right here where it falls on the circle, the xy value will represent the cosine and the sine of that angle. Okay, that will be the cosine and the sine that's created by that angle, all right? This is true for all angles. All angles of the same degree or radian measurement will have the same sine and cosine. Whether it is an angle that you can fit on your paper or what is an angle to calculate where a satellite is roaming in space, all angles with the same degree or radian measurement will have the same sine and cosine. Okay? This is why we use the unit circle, because then it makes it simpler. A radius of 1 makes it simpler. It just changes it down to just the y and x value of where that point falls on that circle with a radius of 1. Because truly, the size of the circle doesn't matter. It's the measure of the angle that matters. Okay? So this is the introduction to the unit circle. Here is the unit circle. All right, so if I'm starting at 0 degrees, 0 radians, okay? I haven't moved at all from my initial side. I'm going to go up by 30s. 30. That's a third of the way around this first quadrant. Then to 60. Everybody see that? 30, 60. 30, 60, 90. I'm just going by 30s. 120. 150. 180 is one that we've talked about, right on your x-axis, right? 210. 240. 270 is on my y-axis. 300, 330, and 360. So the first movement that we do is just 30 degrees around it. 30 degrees around it, okay? So then let's talk about your radians. We're going to move by 1/6. All right, so we're at 0 over pi, we're at 1 pi over 6. 1 pi over 6. 60 degrees is 2 pi over 6. What does that reduce to? 2 pi over 6. That's pi over 3, right? 3 pi over 6. That's pi over 2. Pi over 2. 3 pi over 6. 4 pi over 6 reduces. 4 pi over 6 reduces. 5 pi over 6. 6 pi over 6 reduces to pi. 210 is 7 pi over 6. 240 is 8 pi over 6. All of your evens will reduce to thirds, right? Everybody see that? All of your evens will reduce to thirds. So this is 8 pi over 6. 9 pi over 6 also reduces. 10 pi over 6 reduces to 5 thirds. 11 pi over 6. And then 12 pi over 6. That is 2 pi. Okay? So my 30 degrees relates to my pi over 6s, and my 60 degrees relates to my pi over 3s. Every reference angle, every pi over 3 will have a reference angle of 60. Every pi over 6 will have a reference angle of 30. Okay? Quickly, 45 degrees. 45, 90, 135, 225, 270, 315. You're going by 45s. So the next group in the center goes by 45s. 45, 90, 135, 180, 225, 270, 315, 360. Around the unit circle in radians, they go in fourths. Pi over 4, 2 pi over 4, 3 pi over 4. This is 4 pi over 4. 5 pi over 4. This is 6 pi over 4. 7 pi over 4. And 2 pi is 8 pi over 4. Now here's what I really quickly want to show you. All right? As far as the sine and cosine, you literally just have to memorize the first quadrant because everything else is a reference angle. So let's look at 30 degrees. Memorize the sine and cosine of a 30 degree, all right? Sine is your y value, 1/2. Cosine is your x value, square root of 3 over 2. Let's move across to the reference angle in the second quadrant. So here's my first quadrant, 30 degrees. Here's the reference angle in my second quadrant. Lo and behold, square root of 3 over 2 and 1/2. What changed? My x value is now negative, my cosine. Okay? Look at my 30 degree in my third quadrant. Square root of 3 over 2, 1/2. It's just they're both negative. X and y are both negative in that quadrant. Look at my reference angle in my fourth quadrant. Square root of 3 over 2, 1/2. The only thing that's negative there is my sine or my y. You're done with that one, okay? 60 degrees. The only thing that happens with 60 degrees and 30 degrees is they flip-flop. They are complementary angles. Look at my sine and cosine of my 60. 1/2 square root of 3 over 2. It is the complement of 30. My sine is now square root of 3 over 2. My cosine is now 1/2. Reference angle for 60 degrees over here. 1/2 and square root of 3 over 2. My y is positive. My x is negative. In the third quadrant, negative, negative. 1/2 square root of 3 over 2. In the fourth quadrant, positive, negative. 1/2 square root of 3 over 2. Easy enough? Let's look at our 45, our other reference angle we need to have memorized. This is your easiest. Square root of 2 over 2, square root of 2 over 2. Every over 4 is going to have that sine and cosine. The positive and negative will depend on what quadrant you're in. Reference angle in the second. Square root of 2 over 2 for both of them. Reference angle in the third. Square root of 2 over 2 for both of them. Reference angle in the fourth. Square root of 2 over 2 for both of them. This is your unit circle. Memorization is not hard. Memorize the first quadrant. Recognize the reference angles in the second, third, and fourth.